Today marks the end of an era and the beginning of a new one.
It would be so exciting to wake up in the morning and think that that's what's happening.
There is life on Mars.
Michio Kaku, a renowned physicist and co-founder of string field theory, has always been vocal about the potential of space exploration and the surprises it holds for humanity. In light of recent advancements, Kaku brought attention to a series of compelling discoveries made by NASA on the distant red planet Mars. One such revelation that stood at the forefront was the discovery of water, a vital component for life as we know it. Number 1. The discovery of water. Water, although seemingly common on our blue planet, is not a guaranteed element in the vast expanses of space. The detection of water on Mars, therefore, came as a significant revelation, pushing the boundaries of our understanding about the planet's past and its potential to host life. Through advanced imaging techniques and rovers like the Mars Reconnaissance Orbiter, Curiosity, and Perseverance, scientists have found solid evidence of liquid water in the past and substantial amounts of water ice currently on Mars. These findings were initially based on the detection of specific minerals, such as hematite and gypsum, that typically form in water on Earth. In recent years, advanced ground-penetrating radar tools like the Mars Advanced Radar for Subsurface and Ionosphere Sounding, MARSIS, aboard the Mars Express spacecraft, have provided more direct evidence. They discovered wide swaths of underground water ice, reservoirs, and even a subglacial lake akin to those found beneath the polar ice caps of Earth. By emphasizing these discoveries, Michio Kaku highlights the ever-evolving and complex nature of space exploration. The presence of water on Mars is a testament to the planet's potential for hosting life and the vast unknowns that still await us in the exploration of our solar system. Each finding serves as a stepping stone in our understanding, illuminating the path towards future exploration and potential habitation of Mars. Number 2. Existence of methane. Methane, a simple organic molecule, caught the interest of scientists due to its implications for the possibility of life on Mars. In the past few years, a tantalizing mystery has been unfolding about the existence of methane in the Martian atmosphere. Methane is significant because, on Earth, most of the methane in our atmosphere is produced by living organisms. The Curiosity rover, one of NASA's primary tools in Martian exploration, reported significant methane spikes in Mars's atmosphere that varied with the seasons. NASA's Mars Science Laboratory, housing the Curiosity rover, was equipped with a suite of scientific instruments capable of making detailed chemical analyses, including the detection and measurement of methane levels. Through this technology, scientists discovered that methane levels on Mars oscillated between 0.24 to 0.65 parts per billion, peaking during the Martian summer. Several theories have been proposed to explain the source of methane on Mars. It could be produced by geological processes such as serpentinization, where water reacts with olivine minerals, releasing methane. Alternatively, it could originate from ancient methane trapped in Martian ice cages called clathrates, released periodically due to temperature changes. Another more exciting prospect is that the methane could be biological, produced by microorganisms, just like on Earth. Number 3. Martian weather patterns. The weather on Mars is far more varied and complex than previously thought, as we've learned from NASA's multiple rovers and orbiters. Although Mars is often thought of as a static red desert, it's actually subject to diverse weather patterns, including dust storms, frosts, and rapidly changing atmospheric conditions. NASA's Mars Atmospheric and Volatile Evolution, or MAVEN mission, has revealed details about how the Martian climate changes with the seasons. Instruments on the Mars Reconnaissance Orbiter, MRO, and the Mars Climate Sounder have also provided key insights into daily and seasonal weather patterns. Mars experiences weather phenomena such as the growth and retreat of polar ice caps made from carbon dioxide, similar to the Earth's polar ice caps' annual pattern. Also, the planet has the largest dust storms in the solar system, which can cover the entire planet and last for months. The NASA rovers have also found evidence of frost and snow on Mars. The Mars Science Laboratory Rover Environmental Monitoring Station, REMS, on the Curiosity rover detected humidity, and ground frost at the Gale crater. Further investigations revealed that Mars has whirlwinds, known as dust devils, that are far larger and more common than their earthly counterparts. It also experiences temperature fluctuations that can swing from a high of 20 degrees Celsius during the day to a frigid minus 73 degrees Celsius at night. The study of Martian weather patterns not only aids in understanding the planet's geological history, but also provides critical information for future manned missions to Mars. Accurate predictions of weather patterns would be necessary for landing sites, maintaining equipment, and ensuring the safety of astronauts. The Martian weather, as observed and reported, has shown us that Mars is not just a static, unchanging world, but a dynamic and diverse planet. Number 4. Unusual Martian geology. Over the years, through the lenses of orbiters, landers, and rovers, we've begun to see the intriguing geology of Mars in stunning detail. Michio Kaku often pointed to the unique geological features of Mars, which hold clues to the planet's past and the conditions that might have prevailed there. One of the unusual aspects of Martian geology is the planet's massive volcanoes. The shield volcano Olympus Mons, for instance, is the largest volcano in the solar system, standing at a towering 13.6 miles high, which is nearly 3 times the height of Mount Everest. Its size points to the lack of tectonic plate activity on Mars, allowing lava to flow and pile up in one place over billions of years. Then there's the vast canyon system of Valles Marineris, which stretches over 2,500 miles long and up to 4.35 miles deep, dwarfing Earth's Grand Canyon. This gargantuan geological feature may have formed due to the cracking and collapsing of the Martian crust. In terms of mineralogy, Mars has offered surprises as well. The discovery of a type of mineral called tridymite, typically associated with silicic volcanism, a type of volcanic activity common on Earth but not thought to occur on Mars, has challenged scientists' understanding of Mars's volcanic history. Number 5. Signs of past life. The prospect of life beyond Earth has fascinated scientists for decades. In the search for extraterrestrial life, Mars, with its Earth-like past, stands out as a particularly intriguing candidate. And indeed, NASA's exploration of Mars has yielded promising signs of past life. One of the most significant findings supporting this came from NASA's Mars rover, Curiosity, which found organic molecules, the chemical building blocks of life, in 3-billion-year-old sedimentary rocks near the surface. It also reported a seasonal variation in methane levels in the Martian atmosphere, a gas on Earth that's primarily produced by life forms. These organic molecules don't necessarily prove the existence of past life on Mars, as they can also form through non-biological processes. However, their presence suggests that the necessary ingredients for life as we know it were present. NASA's Perseverance rover, currently exploring the Jezero crater, is on a mission to find more explicit signs of ancient microbial life, known as biosignatures. The crater, believed to be an ancient lake, offers a promising site where signs of past life could be preserved. While these discoveries do not confirm life on Mars, they are pieces of a puzzle that suggests Mars was once a hospitable place for life. The continued search for direct evidence of past life remains one of the most exciting aspects of Martian exploration. Number 6. Ice reservoirs on Mars. Michio Kaku has emphasized the importance of the discovery of ice reservoirs on Mars, a key finding that has reshaped our understanding of the red planet's history and future potential. As we know, water is a fundamental requirement for life as we understand it. The presence of ice on Mars indicates that water, and potentially life, could have existed there in the past and could support future human exploration. Mars is home to the most well-known and accessible reservoirs of water ice. The polar ice caps, composed of water ice and carbon dioxide ice, are visible even from Earth-based telescopes. The southern polar cap has a permanent water ice cap that's about 3 kilometers thick. The Mars Reconnaissance Orbiter, MRO, has also provided evidence of large subsurface ice deposits in the mid-latitudes of Mars. The orbiter's shallow radar, SHARAD, has revealed extensive layers of ice, dust, and rock, which could be accessible to future astronaut missions. Researchers found an ice reservoir the size of Lake Superior, the largest of the Great Lakes on Earth. These subsurface ice deposits are protected from Mars's thin atmosphere by a covering of dust and rock, preserving them for potentially millions of years. The ice is relatively pure, with only about 10% of it mixed with dust. Most recently, researchers discovered signs of a large saltwater lake under the ice at Mars's south pole, detected by the Mars Advanced Radar for Subsurface and Ionosphere Sounding, MARSIS, on the Mars Express spacecraft. This added another layer to the understanding of water on Mars, as liquid water could still exist below the surface under certain conditions. The discovery of these ice reservoirs has major implications for the potential habitability of Mars and for future human missions to the Red Planet. Ice can be used for drinking water, growing food, and even creating rocket fuel. Number 7. The Marsquake Phenomenon. One of the fascinating findings announced by Michio Kaku from NASA's Martian exploration was the detection of Marsquakes. The term refers to seismic activities similar to earthquakes but occurring on Mars. NASA's InSight, Interior Exploration Using Seismic Investigations Geodesy and Heat Transport lander, launched in 2018, was equipped with a specialized instrument known as the Seismic Experiment for Interior Structure, SEIS. The goal of this mission was to study the deep interior of Mars, which included detecting and analyzing Marsquakes. Marsquakes provide crucial insights into the interior structure of Mars, including the thickness of its crust and the properties of its mantle and core. They allow scientists to study Mars in a way similar to how geologists use earthquakes to learn about Earth's interior. Data from the InSight mission have identified hundreds of Marsquakes to date. These Marsquakes appear to originate from within the planet rather than from tectonic plate interactions, as Mars lacks the plate tectonics found on Earth. There are two types of Marsquakes observed: high-frequency and low-frequency. High-frequency Marsquakes are weaker and closer to the surface, while low-frequency Marsquakes are stronger and originate deeper within the planet. The most substantial Marsquake detected thus far had a magnitude of about 4.0 on the Richter scale. Though not destructive like severe earthquakes on Earth, these Marsquakes provide valuable insights into the geological activity of Mars and reveal that it is not a geologically dead world, but one that still rumbles with internal activity. Marsquakes thus represent another piece in the puzzle of Mars's geologic past and present. Number 8. Discovery of organic molecules. Michio Kaku, in highlighting key Martian discoveries, emphasized the detection of organic molecules on Mars, a significant step in the search for life on the Red Planet. Organic molecules are carbon-based compounds, crucial for life as we know it. The presence of these molecules on Mars suggests that the planet may have had the necessary building blocks for life. NASA's Curiosity rover, while traversing Gale Crater, detected a variety of organic molecules in the ancient lake bed. This was done using its Sample Analysis at Mars (SAM) suite of instruments that can heat soil and rock samples to release organic molecules and identify them. Among the molecules found were benzene and propane, simple organic compounds that could be related to larger and more complex molecules. The discovery of organic matter in Gale Crater is significant because the area is believed to have held a lake billions of years ago. The molecules were found in mudstone, a sedimentary rock that forms from mud at the bottom of water bodies. This suggests the potential that life could have existed when the lake was present. It's important to clarify, however, that organic molecules do not necessarily mean life existed on Mars. They can also be created in geological processes or delivered to Mars by meteorites. Nevertheless, their presence is an encouraging sign for the possibility of past life. Number 9. Mars' ancient rivers and lakes. Among the fascinating features of Mars that Michio Kaku often draws attention to are the geological formations indicating the past existence of rivers and lakes. These features provide strong evidence that Mars, now a dry and desolate planet, once had a significantly wetter climate, potentially conducive to life. High-resolution images from Mars orbiters have shown numerous channels, valleys, and deltas across the Martian surface, all signs of past water flow. One of the most compelling pieces of evidence is the network of ancient river valleys spotted on the planet. These dried-up systems are similar to river networks seen on Earth, suggesting they were carved by sustained water flow over a long period. NASA's rovers have explored various locations thought to have been ancient lakes. Gale Crater, where the Curiosity rover landed, was chosen because scientists believe it was once filled with water, forming a lake about the size of Connecticut and Rhode Island combined. Curiosity has found rounded pebbles along its route, which geologists recognize as a sign of long-distance water transport. The presence of these pebbles indicates the existence of flowing water, likely a small stream flow. The Perseverance rover is currently exploring Jezero Crater, which scientists believe was once a lake about the size of Lake Tahoe on Earth. Jezero is particularly exciting because it has a well-preserved river delta where water flowing into the lake deposited sediments over time, a great place to search for signs of past life. The evidence of ancient rivers and lakes on Mars suggests that the planet had a warmer, wetter past where life as we understand it could have existed. While no definitive signs of life have been found so far, these bodies of water offer exciting areas to continue the search. Number 10. The Martian atmosphere. Understanding Mars's atmosphere is key to unlocking the mysteries of its past and planning for future explorations. The Martian atmosphere, as described by Michio Kaku, has intrigued scientists due to its complexity and the insights it offers about the planet's history and potential habitability. Mars's atmosphere is thin and primarily composed of carbon dioxide, about 95%, with traces of other gases such as nitrogen and argon. Despite its thinness, the atmosphere plays a crucial role in the planet's weather, creating phenomena such as dust storms and temperature variations. NASA's Mars Atmosphere and Volatile Evolution, MAVEN spacecraft, has been studying the Martian atmosphere to understand its current state and historical changes. MAVEN's findings suggest that the Martian atmosphere was once much thicker, which could have supported liquid water on the surface. However, over billions of years, the atmosphere gradually eroded away. This atmospheric loss was driven by the solar wind, a stream of charged particles emanating from the sun. Without a global magnetic field to protect it, Mars's atmosphere was vulnerable to these solar winds. The thin atmosphere has significant implications for potential human missions to Mars. It offers minimal protection from solar and cosmic radiation, posing a significant challenge for crew safety. The thin atmosphere also makes landing spacecraft on Mars more challenging, as it's less effective at slowing down spacecraft during descent. Number 11. Evidence of ancient tsunamis. Michio Kaku has pointed to one particularly intriguing and unexpected discovery on Mars: evidence of ancient tsunamis. These findings suggest that Mars may not have been the dry world we see today, but a planet with a considerable body of water. Scientists have found geological formations on the Martian northern plains that resemble the remnants of massive tsunamis. These formations indicate two separate tsunami events, both likely triggered by meteor impacts. The tsunamis would have been enormously powerful, sweeping across the plains and leaving behind large boulders and other debris. The tsunamis are believed to have occurred about 3.4 billion years ago, during the late Hesperian period of Martian history, a time when Mars is thought to have been cold and icy. After the tsunami waves retreated, they would have left behind ice-rich deposits. These tsunami deposits provide additional evidence for the existence of an ocean in Mars's northern plains, a hypothesis that has been the subject of scientific debate. If confirmed, this would imply a substantial amount of water on ancient Mars, potentially providing habitats for life. The discovery of these tsunami deposits also holds implications for the search for past life on Mars. The regions where the tsunamis deposited water and sediment could be potential locations to look for signs of ancient life. These discoveries, along with others, continue to paint a picture of a Mars that was once very different from the cold, dry world we see today. The evidence of its watery past offers tantalizing hints about Mars's potential to host life in its ancient history. Number 12. Polar ice caps. The polar ice caps of Mars, frequently discussed by Michio Kaku, are among its most intriguing features. These ice caps are similar to Earth's polar ice caps in some ways, but they are also distinctly Martian, offering clues to the planet's unique climate and geological history. Mars has two polar ice caps, located at its north and south poles. They are composed mainly of water ice and also contain a significant amount of frozen carbon dioxide, or dry ice. During the Martian winter, temperatures drop so low that a portion of the carbon dioxide in the atmosphere freezes out and adds a seasonal layer to the polar caps. The northern cap, called Planum boreum, is larger and topographically flatter than its southern counterpart, Planum australe. Both ice caps have layered structures, much like the rings of a tree, representing seasonal variations in the deposition of ice and dust. Studies, particularly by the Mars Reconnaissance Orbiter and the Mars Express mission, have shown that the northern cap contains enough water ice to cover the entire planet with a layer of water more than a meter deep. These findings point to the presence of significant amounts of water on Mars, which is crucial for understanding its past climate and potential to harbor life. Furthermore, the ice caps have significant implications for future human missions to Mars. The water they contain could potentially be used to support human settlements, providing a source of drinking water and an ingredient for making rocket fuel. Number 13. Martian volcanoes. Mars hosts some of the largest volcanoes in the solar system, an aspect that Michio Kaku often cites when discussing the planet's unique geology. These volcanoes tell a story of a world that was once geologically active and could still hold some surprises. The most famous Martian volcano is Olympus Mons, which stands about 13.6 miles high, nearly 3 times the height of Mount Everest. It is the tallest volcano in the solar system and is visible from space. This shield volcano is characterized by its broad, gently sloping sides formed by repeated eruptions of low-viscosity lava. In the Tharsis region of Mars, we find a group of large volcanoes, Arsia Mons, Pavonis Mons, and Ascraeus Mons, known collectively as the Tharsis Montes. Tharsis is a massive volcanic plateau, and its formation has significantly shaped Mars's history and appearance. The long-lasting volcanic activity on Mars is linked to the absence of tectonic plate movement on the planet. On Earth, tectonic activity can shut down a volcano after a geologically short lifespan, but on Mars, a stationary hotspot of molten rock can continue to erupt for billions of years, creating gigantic volcanoes like Olympus Mons. Volcanic activity also contributes to Mars' potential for life. Volcanoes can produce environments conducive to life, including hydrothermal systems. They also play a role in the creation of a planet's atmosphere and influence its climate. While Mars volcanoes are not currently active, recent studies suggest there might have been volcanic activity on the planet as recent as 50,000 years ago. This could have significant implications for the potential existence of life on Mars, as it suggests a geologically recent source of heat and potentially habitable conditions underground. Number 14. The seasonal flows of Mars. The seasonal flows, or recurring slope linii, RSL, on Mars, are a unique phenomenon that has captivated scientists like Michio Kaku. These dark streaks appear on Mars's surface during warm temperatures, fade during the colder seasons, and then reappear annually. First observed by the Mars Reconnaissance Orbiter, the seasonal flows usually appear on steep slopes and crater walls. The streaks can extend hundreds of meters and are typically narrower than 5 meters. They start forming when Mars's surface temperature climbs above -23 degrees Celsius, and they disappear in colder weather or when the sun doesn't shine on the slope. The exact mechanism causing these seasonal flows remains a mystery, and they have been the subject of numerous scientific hypotheses. Early theories suggested that they might be caused by the flow of briny water, potentially from melting subsurface ice or underground aquifers. More recent studies suggest that RSL might be the result of dry flows of sand and dust, driven by the sunlight heating the surface. This would make the flows similar to certain types of landslides seen on Earth. Despite the uncertainty, the seasonal flows continue to be of interest because if they are caused by salty water, they might provide a habitat for hardy microorganisms. This possibility presents another opportunity in the search for life on Mars and will undoubtedly continue to drive future investigations. Number 15. Martian night glows. One of the more unexpected findings about Mars is its night glow, a phenomenon that Michio Kaku often discusses when highlighting the mysteries and wonders of the red planet. Mars's night glow, a faint illumination of the Martian atmosphere occurring even without direct sunlight, was confirmed by NASA's MAVEN spacecraft. Mars's night glow is caused by chemical reactions in its upper atmosphere. During the day, solar radiation breaks apart carbon dioxide molecules into carbon monoxide and oxygen. At night, these atoms can recombine to form carbon dioxide again, releasing energy in the form of light, creating a glow. This Martian night glow varies with the seasons, showing a maximum during equinox and a minimum during solstice. It also exhibits irregularities, pulsating about 3 times per night. These variations in the night glow help scientists learn about the circulation patterns of Mars's atmosphere. The ability to study Mars's night glow is significant because it provides information about the planet's atmospheric dynamics, including how winds circulate at high altitudes and how these circulations change with the Martian seasons. Such observations can offer clues about the planet's past and current climate. These discoveries remind us that Mars, like Earth, is a dynamic planet with complex atmospheric and geological processes. As we continue to study Mars, we can expect to uncover even more of its fascinating characteristics, each adding to our understanding of our neighboring planet and its potential to support life.